Section 2.1 Solution curves without a solution. This section will look at direction fields and autonomous first-order differential equations. For direction fields, recall in Calculus 1, dy by dx or the derivative of the function y equals f of x gives slope of the tangent line at the points on the graph. For the first-order differential equations, dy by dx equals f of xy is a slope function or the rate function, where f of xy represents the slope of the line or a line segment, which called a linear element. Direction field or the slope field is a collection of all line elements, and those direction fields suggest the appearance or the shape of the family of solution curves of the differential equations. Let's see examples. Use a direction field to sketch an approximate solution curve for the initial value problem. Number 1, dy by dx equals 2x minus 1 with the initial condition y as at 2 equals 0. For this equation, we have f of xy as 2x minus 1. Therefore, at any order pair x, y, the slope of the line segment goes with 2x minus 1. For example, for the order pair 0, 0, x0, y0, so dy by dx or the slope m would be 2 times 0 minus 1 or negative 1. For the order pair 1, 2, dy by dx or the m or the slope at that point would be 2 times 1 minus 1 or 1. So let's look at the slope field provided. At the point 0, 0, as you see, then m or the slope is negative 1. And at the point 1, 0, 2, the slope is positive 1. The initial condition at the point 2, 0, so 2, 0 is the x-intercept right there. To sketch the solution curve passing through this order pair, you go along the line segment at slope indicated at that position. That's why it's called the slope field or the direction field. It will tell you the direction of the solution curve of the initial value problem. To look at the web-based slope field generator, GeoGebra is one of the web-based that you can use to generate the slope field of the differential equations. For example, the dy by dx equals 2x minus 1. And we can show the slope field without the solution. And then if we want to show the solution passing through the initial point, which is at the point 2, 0, so just move the order pair over at the initial point, which is 2, 0, and the red curve will show the particular solution passing through that initial condition. Next example, dy by dx equals y minus x, where initial condition is y at 0 equals -1 to generate this solution, this slope field. In this case, f of xy is y minus x. If we want to sketch by hand, we just analyze it at where dy by dx equals 0 or where the slope is 0. The right expression of y minus x equals 0, or you can say y equals x. The position that y equals x will give the slope 0. And next, for m or dy by dx greater than 0, therefore y minus x greater than 0 as well. Or we can say y is greater than x will give the slope greater than 0. The greater x, the greater slope in the positive direction. And for m or dy by dx less than 0, y will be less than x. So on the right side of the line y equals x, the slope will be negative. To plot the solution curve passing through the order pair 0, -1, locate the point at the location 0, -1, and then sketch the solution curve by drawing the curve along the slope